neutron multiplication factor K. So this factor is also most important to study about the critical mass, and that will cause the sustained chain reaction, and what should be the value of this K, because when this uranium 235 is fissioned by the thermal neutron, then the fast neutrons are produced. These fast neutrons are 3 in number, and for the further fission it is necessary that at least 1 neutron should be available for the further fission. And if out of 3 all the neutrons are escape from the material, then there will be no fission at all. So this is necessary that at least 1 neutron must be there for the further fission of the uranium 235. It is defined as the ratio of number of neutrons produced in current generation to the number of neutrons produced in preceding generation. It is denoted by K. Denoted by K. It is a dimensionless this means that it has the dimension M0, L0, T0. So no unit. It has no unit. This is a very critical one, because many of the students confuse that there must be some dimensional formula for this critical the multiplication factor K. So this K is equal to number of neutrons in present current generation divided by number of neutrons in preceding generation. यानी इसका अर्थ ये है कि भाई वर्तमान पीढ़ी में जो भी नंबर ऑफ न्यूट्रॉन है और उससे पहली वाली पीढ़ी में, उससे ठीक पहले वाली पीढ़ी में जितने नंबर ऑफ न्यूट्रॉन है उनका ये रेशो होता है, अनुपात होता है। जो ये if k is less than 1, k is less than 1, it means that no neutron is available for the further fission. No chain reaction takes place. चेन रिएक्शन होता ही नहीं है, यानी कि ये क्या है कि अगर स्टार्ट भी हो गया तो तुरंत बंद हो जाता है। सो दिस इज द सब क्रिटिकल मास। मास ऑफ मटेरियल is called subcritical mass. Subcritical mass. If k is equal to 1, it means that this is not equal to 0, but it has the value, and in this case now this number of neutron and this number of neutron are equal, so it means that they will cause the sustained chain reaction. Sustained chain reaction. Takes place. It is the controlled chain reaction. It is controlled chain reaction. Chain reaction. This concept is based on the atomic reactors are based on this concept. Atomic reactors. Atomic reactors follow this concept, and the mass of the material is called the critical mass. The mass of material is critical mass. So this is for k equal to 1. Now if k is greater than 1, it means that the number of neutrons in the current generation are more than the number of neutrons in the preceding generation, so the chain reaction will be uncontrolled and a big explosion takes place. The mass of the material is the supercritical mass. The chain reaction becomes uncontrolled becomes uncontrolled, and a big explosion takes place. With release of tremendous energy. Tremendous energy. So all the atomic bombs are based on this concept. All atomic bombs are based on this concept. The mass of material is called supercritical mass. So this is what's with the value of K, so that the chain reaction will not take place, or it will continue, or this will be uncontrolled. So if the K is less than 1, then the chain reaction cannot continue, and if it starts, then it will stop immediately. If K equal to 1, then this is the sustained chain reaction, and if K is greater than 1, then this is the uncontrolled chain reaction. So all the atomic reactors are based on the fact that this K is equal to 1, but all the atomic bombs are based when this K is greater than 1. So the question is asked in the competitive exam, that what must be the value of the multiplication factor for the sustained chain reaction, non-sustained chain reaction, and also the subcritical mass, critical mass, or the supercritical mass. If subcritical mass, then K is less than 1. If it is the critical mass, then K equal to 1. If supercritical mass, then K greater than 1. So this is about the neutron multiplication factor K. So thank you very much.